Hello. We have introduced some of the most basic syntax aspects of the SuperCollider language, and for the occasion, we've been able to create a small program creating a graphical interface. Now, this small program was, let's say, perfectly functional in the sense that it was autonomous and it allowed us to create graphic interfaces doing certain things. Well, not particularly interesting things, but that's another point of view. So, are we finished with the basic aspects of the language? Well, of course not, even if we are on our way. And of course, there are many things concerning the language. The point is that thanks to the integrated help file system, you will be able to explore the language and all its features by yourself. That's the way I learned SuperCollider. The point is that we just need some basic aspects like a foundation allowing us to move by our own way. So we're still missing something, and we're missing something which is related to the so-called control structures, because in some sense the very same idea of object oriented programming is related to some sort of communication between objects doing various different things, but there are some basic programming structures that surely need to be introduced. And in order to do so, let's go back to graphical user programming and let's make another program. So, in order to make, let's enlarge this font, and we make a window like W window. We start with our environment variable, using single letters, so it's easy for us to interact with the program. Environment new, and let's do something like this. We create so you know that now we are creating a new window, assign it to variable W, and asking this window to pop up, and here it is. So there are many graphical objects that are available to you to work with, such as not only a knob but slider, number, boxes, and so on. And for the moment we are introducing a new one, and guess what? It's a button. So button new, I am omitting new, button new. You see that it works like knob, so we need a parent, and it's W, and we need bounce, and we will do a mega button. So if we do this, you can see here, and you might say, hey, but there's nothing here. It's just like the window we created before. It's not true, because you see, you can click it and something is happening. Now we have creating a mega button which is covering exactly all the surface of the window, and you see that we can click it. Something is happening, at least graphically. Of course, nothing is happening in terms of action. So can we tweak this mega button a little bit? Sure. And we have states, so we are assigning the states attribute of button. Button is a multi-state button. Now how many times you can press on a button while it keep changing its state? Well, typically a couple, so on, off. But it's not true. Maybe in general, maybe you know of buttons that can have 3 states. In SuperCollider, the button element can have as many states as you want, even if most typically you will use only 2. That's the way we will do. And what is states? States, it's an attribute, a property, and it requires to be set up an array because we are passing a container of different states. So the array will contain the state 1, then the state 2, 2 elements of our array. Now, what is a graphical state for a button? Well, it is made up of arrays. And as you can see here, there is one here and another one here. So, of course, until now we used an array as a container for numbers, but an array is a general container for anything that we need to put into it. And in this case, our array contains as its own element arrays. In particular, these single arrays will describe the internal parameters of each of the 2 states we are defining. And typically, if you go to button help file, you will see that the first example provides you some interesting information. Now, the first element here is a string, which is the label on your button. Then a couple of color, like black and color red. And we can use formatting to better understand what is going on here. You see I'm changing line. So the second state could be something like this. I am inverting the color just to make sure we see the difference. So let's evaluate this line. You see why am I using environment variables, because I can interact with the code. So now there is our mega button as a small label, of course, which is start, and as you can see, the color of the string is black, color black, and the background is red. Now we can press it, and what happens is that we are changing the state to the next one. So states is an array of states, and while clicking we advance in this sequence. Point is, when we reach the end, what happens? Well, it simply wraps around. So by pressing it again, we are at the beginning, at the first element of our array. As you can see, here I have stop colored in red, and the background is black. So that's how we create buttons. Of course, this is just the graphical elements. We're doing nothing with this button, but that's the point we will address from now on. Now, an interesting thing here is that in order to define colors, I've not used this or this kind of syntax we were used to, but I've used something like this. So let's look at this from a syntactical point of view. what am I doing? I am sending a message to the class color saying, hey, class color. This means give me a red. This is a constructor method because it returns an instance of color, and of course it's pretty useful to be simply able to ask for a red or a black or a green. So many basic colors are available as with this kind of syntax. So class color, give me a red, give me a gray, give me a black, and so on. So from a syntactical point of view, this kind of syntax is exactly like this. It's a constructor method returning an instance of the class color. Now, point is that we have our, well, there are many graphical aspects that can be tweaked. This is up to you. You can change the font, you can change the dimension of the font and whatever. By the way, as you might think, in order to change the font, there is a font class. That's always the same kind of logic at work, but we will not deal too much with this. Rather, we will focus on the action. So, as we knew from knob, we can bind an action to the graphical element. And in order to do so, we did something like this. In that case, it was a knob, but the point is exactly the same. So, object B, that is button B, set, this is the setter syntax, set your action as what? Well, an action we've been used to describe it in terms of a function, and in fact we are describing again, also in this case, the action of the button as a function. So let's try this. And now we click, and every time there is a change in the graphical state of the object, like every time there is an increase or decrease in our knob, in this case the change is discrete. So we go from one state to the other one. Every time there is a change, then the function is evaluated. So the program contained into the function, the code contained into the function, but it's a program, is evaluated, the code, and the program is run. And now our simple function simply contains, let's call it a post line invocation, so printing on the screen. So every time we press, we get this hey on the screen. So of course you can do whatever you want here, and in order to see something related to sound, because at the end you are here for sound, but we're still not dealing with sound, maybe you can remember something like this, and you know that this will produce a sound, a note. Now, we have no idea for the moment why this should happen, but we can treat this kind of things as a black box, assuming simply that it works. That's interesting in terms of programming. So we do not know why this generates a sound, fine, but provided that the server is booted, in my case it is already booted, provided that the server is booted, you will have this piece of code generating a sound. Now, note that we are sending a message to these strange things. So, a strange definition of something, please play. So for the moment, what we need to know is simply that this is a sort of parameters setting the pitch of the note expressed in MIDI notation. Maybe you know that MIDI, the MIDI notations, the international code says that 60 is the middle C, the C between treble and bass clef. So this is 60 by convention, represent that C, and every half tone is represented by an integer. So this is C sharp and this is D, and so on. Fine. So we can use this as a sort of black box for our first experiments. Now, as an example, let's go back to the basics, that is to middle C, and we replace the action with this. What happens here? Now, a function can contain whatever we want a program to be executed, and we know, even if we do not know why, we know that this will generate a note, something like an electric piano note, middle C. So if we evaluate this, every time we press, the function is evaluated and we get our middle C. It works like a sort of, mistake alarm when you try to do something on your computer and you cannot. So you get in bing, little bit boring. Now, the interesting point here in both cases, well, an interesting point is that this is simply how we bind graphical objects to sound generation. So of course we will see much more complex ways of creating sound, but the point is that in order to bind a graphical object to a certain sound generation behavior, we simply specify what we need in terms of expressions inside the various actions of our objects, of graphical object. First element. Second element. Now the point is that we have two state button and one behavior. Now typically what happens is that when you press that button on your wall, you are assuming that you're switching on the light, and when you press again the same button, typically in a two-state configuration, maybe you press it on, it remains pressed on top, and maybe you can press it so that it remains pressed on bottom. Well, you're switching off the light, so you have two-state physical behavior that represents a two-state light condition. So it's just like having something working as a sign for the other, and you should have something representing the two conditions you want to obtain in terms of the physical button, or seen from the other point of view, if you have a two-state button, well, it makes sense that it controls a two-state situation. But in our case, we have two-state button and one single situation. Bing, bing. That's why it works like a sort of, mistake alarm. So the point is, we need to switch, in some sense, switch on off, to switch between two situations. So we need to know where we are in our sequence of states of the button so that we can do different things. So we started writing start and stop. Well, it is assumed that maybe we're starting doing something and stopping this action we're doing, or maybe we can have we can have two different possibilities, like let's say C, play C, and play D. Maybe you want to have a C note, and by pressing it again we want to have a D note. How can we do this? Well, the point is that do we know where we are? That's the first point. Yes, we know where we are, because actually if we do something like what we did with knob, we have a similar situation. Now what happens is that if you remember, there is a function, of course. This function is passed by default the same object when it is called by the program. So here we're using this, I'm calling what is passed, that is the button in our case, as me, because it's a sort of reflexive behavior. Note that you can call this jack if you want. That's the same, but the point is that these represent the very same button passed to the function, so that you can access to this object from the function itself. So it makes sense that we use something meaningful as usual. Or you cannot use this, because this is a reserved word. You can use self if you want, but it might get confusing. I like to use me. It's short and clear. So if we assign now this action, we are overwriting it. We are assigning this action to our button. What happens is that the button posts its value. What is the value of a button? Well, let's clean up a little bit. Well, as you can see, it is posting on the window 1 and 0. So this is 0 state, the index of the state, and this is 1 state. So by passing the index of the state in which the button is, we know where we are, and we are able to define our behavior in relation to that state. So the point is, if we are in state 0, we can do something. If we are in state 1, we can do something else. And in case of multi-state buttons, well, of course, we can say if we are in case 2, we can do a third thing, and so on. Now, the point is that syntactically, well, in English we say if, but what should we say in SuperCollider? Do we have if? Yes, we have. So typically we need a conditional statement, and the conditional statement, before putting it inside our function, works in this way. I'm using the shortest version, which is easier to remember. So if true or false, or better, if true, do this. If not, do this other thing. That's the way it works. So of course this is not SuperCollider code, and we need to place inside these 3 blocks SuperCollider code, but the point is, this is the condition we are taking into account. This is what happens if this first condition is true, and if it is not true, that is, it is false in Boolean logic, then do this other thing. You can appreciate the usage of curly brackets, because it's like a function, so it's like 2 different programs. If you want 2 different blocks, they can be evaluated in relation to different conditions. So let's consider Jimi Hendrix. If 6 equals 9, do this. voodoo child post line. So this means that if 6 is 9, so if this is true, then this will be printed on the screen. If not, then this will be printed. So like now, if 6 was 9, of course it's plainly impossible because 6 is different from 9. And so what happened is that we have "Hey Joe." Now in this case you can appreciate that this is a double equal sign, because this means equal logically. This is not equal, but it's assignment to variable, like v window new. So here the equals means w, sorry, I'm using v, which is Italian, w is assigned this. Later, this double equal sign says check if these two are the same, are identically. So you need to place double to check logically. So we can maybe say if 6 minor 9, that's not so much Jimmy style, but yes, 6 is minor than 9. So in this case, what happens is that as this is true, this branch, this conditional branch, is evaluated. And in fact, there is voodoo child printed on the screen. So there are many other conditional structures in SuperCollider. I'm leaving the exploration of these conditional structures to you, like case, switch, and so on. But basically, the point is always this one. So you get various conditions and various conditional branching. And as you can appreciate, this is like a function, and a function is not like, it's a function, and the function returns the evaluation of the last expression. So if we do something like this, f is assigned what is returned by this expression. Guess what is f? F is a string. This string in this case. So f is a string, and if you want to see the first character, you see that we have v, the first character of the string. So this kind of construct can be used, by the way, if you want. So you can assign a variable in relation to what happens in a condition. In our case, we will stick to a more traditional way of writing this. And this conditional statement is quite interesting for us because, well, we can put it exactly inside our button action. In fact, here we know where we are, thanks to me value in this case, and in relation to this state we can do different things, like, let's see what happens. If me value is 0, first state, then we do something, otherwise we do something else. And what can we do? Well, we can do something like audio related, like we're using our black box synthesizer, and if it's false, then we are not in well, let's place it, well, sometimes typically you see this kind of alignment, and which I do not like very much. For me is a little bit confusing, but it's typical of the SuperCollider syntax. I prefer other kind of indentation. You can, by the way, auto indent following the best practices your block of code. So if you do something like this, which is quite messy, you can select this block and go here and ask for auto indent. Well, in this case it was a little bit too messy, but that's how it can work, at least for indentation. So okay, so our action is this one. So it means well, let's do this in this way, maybe it's clearer. Sorry. And this was a little bit of our mess. I'm typically leaving spaces, which is not, which for me it's clearer. So it happens that this is what we have to evaluate. If mi value is 0, then do this. In our case, we just have two cases. So if it's not 0, it must be 1, and if it is 1, then this other block is evaluated. It means that in one case we get a C, and the other case we get a D note. So let's see. Now our button is a little bit confusing. Well, I have decided to destroy the button because it's easy, but it was not necessary. I could have simply updated the states function. Made a mistake. This is our new button. Play C. No, it doesn't work because we haven't associated the action to this new button. Here we are. See? That's interesting because we have added a layer of intelligence. You know, there is this joke that artificial intelligence is just a bunch of if. Well, because actually what happens is that by adding conditionals in various ways, we are able to evaluate different conditions, different situations, and behave differently. That's a crucial point. Now, so if conditional branching is very important in the organization of complex programs, interesting programs, there's another aspect which is crucial. So I guess you remember that I say that when you find yourself copying and pasting blocks of code, well, there is something wrong. There is something wrong because typically a computer is very good at replicating a certain behavior, and if you're doing this by yourself rather than assigning this work to a computer, well, there is an issue. There's an open issue in the way you're writing. So the point is, now we have a 1 mega button. Let's try to create a smaller button. So I have closed my button and making a smaller version. So in this smaller version, you see that the button is exactly the same as before from the point of view of colors and also behavior. And it's a small one. It's a small one, and as you can see, it is placed in the point 0, 0 of the window, meaning the top left, and it's large 50 pixel, and its width is 50, and its height is 50 pixels too. So it's a square button. 0, 0 means top left. That's a typical way of behaving in graphical interfaces in your computer. So 0, 0, the origin is in the top left. Now, fine, let's suppose you want to make small keyboards and you want to add many keys. Well, of course, you have a lot of space here, 10 by 10, fine. And how do you add buttons? Well, you might say, okay, it's a button with this kind of action, then we can add the button C, and maybe we will change the note and we will set the action. Then I will have a button D and so on. Well, by having 3 buttons and without updating all the code, you have this mess. Now let's suppose you want to make something like 20 buttons or 50 buttons. or maybe just 12 buttons, well, the code becomes really messy, difficult to navigate, and difficult to debug, because let's suppose there is a sort of relation between all these buttons, and if you have failed to, and if you made a mistake, maybe this mistake has propagated through all these buttons. So that's a really bad way of writing code. Is there something more clever that we can do? Well, let's go back to where we were before, that is to be. And first of all, we need to clear out our ideas. What we want to do. Do we want to fill our space? If we want to fill our space, maybe we just want the interpreter to make copies or make different buttons placed in various places, locations in our window. So maybe we want to fill up the first line. So we want to have a set of buttons, one after the other. Now we know that the width is 500, and assuming that we want to have 50 pixels width for our button, then we can use 10 buttons, a sequence of 10 buttons. So the idea is, interpreter, please make not one button and then make another button, but please make 10 buttons. So we need iteration. We need to repeat our behavior. How do we repeat? Well, every one of you who has attended or wrote small code, you know that together with if, the other construct is for. For means repeat something, so conditional and iteration. So now we are at iteration, and of course in SuperCollider there is for, but it is not the most idiomatic way to implement iteration. The most idiomatic way to implement iteration is another one, and I will start introducing this again by using array. So suppose we have an array and we fill it with numbers. We know that an array, well, it contains various objects, but it is a single object itself. And we know we can make many things. We can send messages to these containers. Another message we haven't seen yet is this one. Scramble, just mix up all the contents of the array, which is an interesting kind of behavior. And so we saw mirror, we saw reverse, and whatever. Now actually there is also this kind of message we can send to array. So we say, hey, container array, please do something. And do something takes as an argument a function. We know that this is a function. Now, don't be fooled. This in particular is the argument of the function, and I can place it here so it's easier for you to see. So actually the point is that do, and this is an argument of the message we are sending, and in this case we're passing a function exactly like here. So let's see what happens here. You get a lot of hi. Why? Well, actually because do says that for each element in the array the function will be evaluated. So as we have 1, 2, 3, 4, 5 elements, for each of these elements we get an hi on the screen. So it is interesting because it is iterating this kind of behavior. Now, so iteration can be done in this way for collection-like objects. Point is, well, fine, I am repeating something, but in a case of collection, is there any way I can have information on where I am in the iteration. In particular, maybe I'd like to see that I am working on the first element and that the element is 1, and maybe that I am in the second iteration and the element in this case is 2, and maybe the third iteration, and in this case the element on which I am iterating, the element of the array, is 3. So the point is that if I am scanning the array, I'd like to do where I am and what is at that place. Is there a way to know this information? Yes, because this information is passed to the function, and you are free to use it. Now, again, these are totally arbitrary, but we typically use meaningful names. So the first element which is passed to this function is the item we are iterating on, and the second is the index. So the point is that this function is evaluated at each time, so for each element, and each time this function is passed the item, so the element on which we are iterating, and its index. So we are free to decide to use this information or not. In the first example, hi, we are not using it, and in this case we are accessing it, but we are still not using it. So can we do something more clever? Well, like item index post. So let's change a little bit lines. So here what happened is that we are creating an array just in order to post it, so to have something to be posted in which we understand where we are, and then we are adding a hi, our usual hi elements string. So you see 1 0 2 1 5 2 4 3 7 4. So the first element is the item, the second element is the index, and so we have a complete access to all the elements of the iteration, meaning where we are, what is at that place. Now this becomes very interesting. So this do method receives a function which is performed for every element of the collection we are to which we are sending this message. Now the do message is also interesting because it is polymorphic, meaning that it can be used also for another kind of object. So not only for array or collection-like object, because most of these collection-like objects behave the same, like array, set. There is a strange object called bag. There are various kind of specialized arrays. Many times they behave in the same way. But it works also. Do works also for numbers. Like, let's assume we have. Let's copy and paste in this case. So we can do something like this. Like, how do you read this? You read it in this way. Hey, number 5, please do what? Evaluate this function for a number of times equals to yourself, from 0 up to yourself. This means do 5 times. So when you have 5 dot do, well, you can read it as 5 times do. Now, of course, there is no more the idea of objects of the collection on which you are iterating, like here, but there's still an idea of where are concerning where you are, meaning is it the first or the second or the third iteration? And so actually you have simply one argument which is passed to the function, which is the index. So if we evaluate this, now we've got, well, we have an array which is useless in this case. It's harmless but useless. We simply post a number 0, 1, 2, 3, 4. We count from 0 in computer science, mostly. Not always, but mostly. Well, this means that, well, this is very powerful because you can iterate over collections. And is also because it is the preferred way to implement iteration in SuperCollider is exactly to do this. You want to do this 5 times, 5 dot do. Hey, 5 do this, and you pass a function. So let's go back to our case. So suppose that we know that we want to create 10 buttons. 10 buttons. We want to create 10 buttons, so we can do something like this. 10 times do what? Well, actually this should be something like create a button. We can add a comment. So that's what we want to do. Create a button. Is it enough? Well, actually the creation of a button should also including an action. Maybe that's a way in which we can do this. So we will create a small keyboards. How can we do this? Well, actually we know how to create buttons, so we can restructure our code, and we know that this will mean create a button. So what happens to be variable? Well, actually we'll have many variables. Do we need these variables? Maybe not. We just need to create buttons if we are doing once. So we were using environment variables because we were tweaking and changing what happens, but maybe we are creating in one slot all what we need. So simply create a button. The parent of the button is W. Fine. Now there's the tricky point. Where do we place it? Well, if we do this code will work, but the point is that the buttons we are creating will be all placed in the same place. So let's close this and let's see what is happening. We know that the first argument is the we can say the counter of the iteration, so it's E. So we could think about having and we're using message chaining, having a button showing as a label, a single state button showing as a label its order of creation. So we make an array of states containing one single state. If you want, we can write it in this way. Here we convert the object to string. Probably it's useless. It might work the same, but let's be clear. So it's is a number, and here we are converting it into a string. And then color black, color green. So this is not useful anymore. Here we have the window, and here we create our issue. It's here because we added the columns, but actually the semicolon should be here. Now, as you can see only one button numbered 9. Why? Because they are stacked one on top of the other. Of course, it does nothing. but actually we see always the same place. Now the tricky point is we want to iterate this behavior, but we also want to display as a sequence the buttons. So the point is that have we something explaining to us how to providing us information to display sequentially the button? Yes, because it's a counter. The counter goes 0 to 9. Now the point is that if we think about the place, well, the dimension are always the same. The top is always the same because it's a strip. The point is that we're moving with which step? Well, the step must be 50, which is the width of the button. So the point is that we have 0, 50, 100, 150, 200, and so on. So the point here is that we simply do this. This is the X position, and we say E multiplied by 50. So let's think about iteration. 0 times 50, 0. We start from the beginning, but then this becomes 1 times 50, 50, and then we have 2, 100, 3, 150, and so on. So we are placing sequentially all our buttons. So let's we have closed it, so we can do this again, and at this point something cool is happening. So creating a GUI algorithmically can be a little bit more complex and boring. But boring, it depends, because you can do many complex things in just one shot. That's the point of programming a GUI. So as an example, now these keyboards, this keyboard is doing nothing. But what about this? Here we are creating a button and setting states, but we can also, using message chaining, sorry, today I'm a bit, I have some issues in speaking, action. And the point is, what do we want to do here? Well, maybe we'd like to have a sequence of pitches, just like a sort of keyboards. So going from C sharp, D sharp, and whatever. Can we do this? Yes, we are still need to know where we are, and we know it by using the counter I. And so let's use our black box construct like this. Now point is very easy, because MIDI note is 60 plus, in this case, E. So when we start E, I'm sorry, I'm reading it like E, I, the counter is 0, so this becomes 60. When the counter is 1, this is 61, and so on. And so we have the chromatic sequence from C to B. So let's see what happens here. We made a mistake. That's why it sounded, because this must be added as a function in order to be evaluated only when we press. Let's see. Well, that's not bad. So, can we make these a little bit more structured? Well, you see that here we have a window, and we know that, well, this is just 10 times, so it's not an octave, so it's not going to be. We'd like to go to B. That's an interesting point. So 12 is an interesting number. The point is that if we need 12 buttons, we need to have a certain step of this button. There should be a relation between these and these, because we want to make a container for 12. So the point is that we might have t, which is 50, and at this point, if t is 50, this should be like something like t times 12. And maybe to have a square arrangement, if we want to have a square arrangement, we can do this. And here we have t, t, and t. So we're making this code a little bit more modular because we are relating all these graphical variables to a step variable, which I named here t. So let's see what happens. Well, actually, it works like it should. This time is 0 to 11. Fine. And what happens if we change these to, well, let's say 20, make it really small? Well, actually, the code works the same. We don't have to scale it back. It's simply smaller because they are all related to these step parameters. Maybe we could also decide that we have a sort of module M, which is 12. So I stick to 12 because it's an octave, ma Italian ma, but so let's see. First of all, let's see if this works. So exactly as before, as we were expecting from 0 to 11. Now what happens if we have 24 here? We should have a sort of, double octave. And you see that here we have and so on. Of course, we can try to make this a little bit more complex, and we can try to fill all this space, and we know that it's related to M, so we will have a 12 by 12, but that makes a little bit too big maybe for our experiment. Okay, but okay, let's not make things too complicated. The point is that you can program a GUI and you can do very interesting things, because as you have seen, we've been able to define a couple of parameters that actually can make the code really modular, and this is a good way of organizing your code. So the power of this kind of construction is that we are not bound to a certain measurement or to a certain value, and we can change it and change it on the fly. By the way, in this case, I was closing and reopening the window, but of course you can do this in an interactive way. Maybe you should work with a little bit more complicated code, but that's surely this is possible. This is just one of the possibilities of making this. We're doing this 12 times, we're creating a button, but we could also work in this way for the same So what happens here is that well, let's see if this works. So let's comment this because we like it. So we do not want to lose this code, so we are commenting the code, which is a typical action while you're programming. Now we're closing, yes, the window is closed, and let's see if this works as expected. Yes. So you might see that this works exactly as before, but it's a different implementation. What happened here? Well, fill is a very interesting constructor method. It means that it's a message we are sending to a class, and the class is sending us back an object. So rather than having new clear or having series, here we have fill. Fill is a generic, how can I say, filler for an array, in which we can define what happened, the number, the dimension, the size of our array, and then specify a function that will be evaluated for all the elements of the array in order to compute the value of the element. That said in this way is complicated, but let's array fill for element, the function. So for 4 times an element of the array will be created, so the array will be of 4 elements, and for each time, for 4 times, the element will result from the evaluation of this function. Now this function only contains a string, so all the elements of array will be the string test. So if we assign this to a variable, now what is a? A is this. The resting point as usual, arg. We can, as it is a form of iteration, we can use a counter. So as an example, this means that we are accessing the counter which is passed by default to this function, and we're using the counter itself as a way to compute the element. So 4 element, an array of 4 elements, 0, 1, 2, 3, containing the counter. To appreciate this, 4 element containing the counter times 5. 0, 5, 10, 15. So this is a very powerful way of creating arrays. In this way, here we are creating an array of m, which is 12 elements, with this function. Now this function accesses the counter 0 up to, in our case, 11, and creates a button. So the array, let's call it A. Let's close this, make this gain. Now the result is always the same, but what happens here is that we have an array A containing 12 different buttons, and we can access to this element if we want. So what is A0? A0 is a button, well, sure. And can we access to its state? Yes. You see that I'm speaking about this, of course. So we are accessing to the first element, which is this button, and we are asking this button, A0, tell me your states. And we see that states is a single state with a string 0 and a color which has not been set, color black. No, it's simply black, and another color which is green. And so we could do something like, for each element in A, that is in our array of button, let's do something like arg BT, because it's the button, the first element that is passed. This is the counter. Maybe we will not use it, but what we will do is that we will say A states is, no A, but BT states, the element states, will not be like this. So we're changing the color, actually. It will be the counter as string, and we'll do color black and color, let's say, red. So now we are changing again in an interactive way the elements. Why? Because the buttons, because we have placed the buttons inside an array A. The array is accessible, and by placing the button inside the array, we are able to access them by means of an iteration over the array A dot do means A do for each of your elements, which are the elements of A, of course, are accessed via BT and I. Well, BT is the element itself, that is each button, and I is the counter. And so we are resetting the counter and changing the color. So maybe we do not want to use to start from 0. Maybe we want to start from 1, and now it looks like the same, but it is not, because you can see that the labels on our buttons, they start from 1 rather than 0. But maybe we want to show the MIDI note, and if we want to show the MIDI note, simply we will have to do something like this. So now we're changing it again, and it shows up. All the buttons shows their their MIDI, their associated MIDI note. So that's the way we can work with object and construction. Of course, do we want to transform? Well, maybe we want to transform this in a, rather than using I think we missed something. No, it's not. So here, rather than using 20, which is the step. Now the point is that our variables are not so, they have no meaningful name. So let's do a real program like var step. Let's do a sort of editing. Var, this is number. So now we have step for number, and we have step for number, and now we have we need another array, which is var btr, which is an array, and we say that, and maybe also window. So this will be window, and we call this keyboard, and rather than having it step per number, we just use step. So we have a single strip. Let's change this to something a bit more interesting. We can use 40, and we can use 2 octaves, and now this will be BTR. So we're making a review of the code and making it more readable and a more structured program. This should be number. We have to do this by ourselves because in other programming languages they can have they can provide you some help in do this sort of automatic rewriting. In this case, in SuperCollider, we need to do this by ourselves. But okay, so BTR, this doesn't make a lot of sense. because it is better if we to do this in one shot, as we're creating a single program. So we clean up. And let's see. Now this should be step. This should be step. And this should be step. So we're just rewriting with the new convention for our variables. So now we have this 24 keyboard. So this is we have in the end we have created a small program. Of course, it doesn't sound really good because we just stick to the default sound behavior. But the point is that we've created a program, and we have also created a graphical user interfaces, something working. Well, just need a little bit of fantasy, because this is a way in which you can create interfaces for playing live. Of course, you will have some more complicated graphical user interfaces. You will have more complicated sound generation processes, but the point is this one: create and associate, and do this in a modular way, do this in a well-organized way. So let's look back to our program. We used the parentheses in order to create a block and in order to say to the user that we want to evaluate all this block in one. So we can do a double click here. Then we declared first block the variables we are using. We create a window and we create this block of elements by means of this kind of construct. We're not using it anymore, but actually this kind of this way of thinking might be useful as a how can I say, mind shape for more complex programs, because if you have placed all your object inside a container, then you can work on that container. So in this case, we're not working on that container anymore, it just works. But maybe in more complex system, you can decide that the user can in real time change the whole dimension of the keys or the keyboard. And if you have placed the object inside an array, well, you can do this in an interactive way. So we have started adding a little bit of sound, and then we will add more and more sound.